Now, the sets and relations and functions is the topic we are going to learn. In that one, the first one is sets. First of all, the word set is most generally used, and whatever the mathematical word is there, if you see its literal meaning, then obviously you can understand what exactly it is. So set means it is the collection of well-defined objects. Set is the collection of well-defined objects. Everyone knows it. I don't think you have this in your school level. Do you have it? Set theory?
Yes, sir. In
Yes,
sixth
sir.
standard.
Yes, sir.
Okay, in CBSE or state board or ICSE?
ICSE.
IGCSE.
ICSE they have, but the remaining I think
IGCSE.
remaining syllabus I don't think you have it. CBSE and the state board, isn't it?
No, sir. SSE have had means.
Okay.
Yes, sir.
That's good. So set is the collection of well-defined objects. What is the meaning of well-defined? Well-defined means it should be well-defined mathematically. For example, if I say the number of intelligent students of your class, then it is not well-defined mathematically, and hence it won't form a set. But if I say the number of students, those who have got more than 90% in their 10th class, if I say like that, that definitely forms a set. So set is the collection of well-defined objects. And what is not a set then? That's what I have taken the example. The number of rich people of Mumbai, if I say, the number of rich people of Mumbai, if I say, that will not also form a set. That will not also form a set. But if I say the number of rich people of Mumbai, those are holding 1,000 crores. Those are holding 1,000 crores property. If I say that, then definitely that forms a set. And any one of our class students, those who are holding 1,000 crores, please raise your hand. You can show your thumb here. You can show your thumb here. Those are holding more than 1,000 crores property. Anyone is there? Rishikesh, Ananya, Rachit, Darshan, Divya, Miloni, Prasad. Do anyone have 1,000 crores of property?
No, sir.
दर्शन ने उंगली दिखाया है, उसको पकड़ना है। मैं मुंबई आने के बाद पकड़ूंगा उसको। ठीक है दर्शन, मिलेंगे एक बार।
Yes, sir.
मेरे को थोड़ा इन्वेस्टमेंट चाहिए बेटा, आपसे ले लूंगा मैं। So if it is mathematically defined, तो हम उसको क्या बोलते हैं? Set बोल देते हैं. If it is not properly defined mathematically, then we don't take it as a set. Now, what are the applications of set? Set is everywhere. What I say, whatever mathematics you are learning, there is for every mathematical topic, there are lifetime applications. What I mean to say, real life applications. Real life applications you have for every mathematical topic, whatever you are learning. Similarly, sets has also mathematical applications. That's what the image slideshow you might have seen. Of course, whatever the image now you are seeing is, of course, it is operations on sets, but you have sets applications everywhere in every industry. In any presentation, we will be, it is easy to present anything through the sets. So you have to understand this is a real life application topic is set theory. Okay, now let us understand. Let me wait for the images to roll on. These are finite and infinite sets. I will be defining that. These are all the definitions we will be understanding separately, but I have taken null set or empty set, which has no elements in it, equal sets. These are all the definitions. We are going to see all this. Just for you to familiarize this, I have taken this. Subsets. So if you take PCM is a subset of MJ College. Set theory in the field of economics. In the field of economics also, the set theory is used. Okay. Similarly, in any presentation, if you make use of sets, that will give you really a great impact, and that will make the presentation very easy. And these are Euler's Venn diagrams. Okay, these are all the images. See how he has presented this, developing 21st century critical thinkers. So he has made a presentation. See this one, web analytics. So what does it mean? This is the bigger set is the clear green color, and the remaining sets, they are all subsets. Like that, if you understand set theory, whatever the presentation you have, you can represent all of them. Through the set diagrams. Those set diagrams are said to be the Venn diagrams. So we'll be seeing that. Okay. Now let me share the screen and let us start the theory of sets. Okay. Now this is the definition just now I taught you. The set theory. A set is a well-defined class or collection of objects. By a well-defined collection, we mean there exists a rule that the help of which it is possible to tell whether a given object belongs or does not belong to the given collection. The objects in sets may be anything: numbers, people, mountains, rivers, etc. The objects constituting the set are called elements or members of the set. So it should be well defined first of all. Next, how do we represent the sets? Sets are represented in two methods. One is roster method. Second one is set builder method. Set builder form or rule method. Roster form means you might have heard the word roster. In any factories or industries, there is a roster. Do anyone respond? Did you hear the word roster? Not R-O-A-S-T-E-R. R-O-A-S-T-E-R नहीं है ये तो R-O-S-T-E-R है. Roster means for all the workers there will be an attendance book will be there, that is called roster. Of course nowadays it is all become online and they are using biometric nowadays. But roster means list of the elements presented. That is, if you take, for example, the ovals of English language. The ovals of English language, the order in which the elements are written is set without no difference. A-E-I-O-U is the ovals of English language. They are all written in the flower brackets. These are the flower brackets. In the flower brackets, if you represent the set notation is given in the flower brackets. Remember that. In the flower brackets, A-E-I-O-U is there. So if you list out all the elements, this is called the roster method. So that's what it is. Very simple to understand that. I need not have to expand it more. Similarly, this is to be understood carefully. That is set builder form. What is set builder form or rule method? See, we will be giving the relation in the form of a rule, in the form of a set. See, for example, I want to represent the say AEIOU. AEIOU is ovals in English language. So if I want to represent in the rule in a rule method or set builder form, how do I represent it? That's what I'm writing now. Sets are generally denoted by capital letters A, B, C, and so on, whatever, X, Y, Z. So capital letters represent always the sets. Okay, now if I want to represent this one as set builder form, as a rule method, in the rule method, then how do I represent it? I have taken some set X. Set X is equal to flower brackets begin. This is always common to represent the set. X is such that we write it like this. We read it like this. X is such that we can use like this. Colon, two colons. That is a colon, two dots here. X is such that X is equal to vowels of English alphabet. We write it like this. Vowels of English alphabet. This colon can be used, or even you can use the slash also like this. This can be read, this can be written like this. This is read as such that. It is read as such that. So that makes no difference. That makes no difference. Both are same, but these are listed out. In the roster method, what happens? You can see all the elements that are present in the set. In the set builder form or rule method, you will be finding only the rule that determines X here. Here the rule is we need that X which contains vowels of English language. Which contains vowels of English language. That's what it is. Let us see the examples. If you get any doubt, you can disturb me in between, please. You can disturb me, you can ask me. Please do not keep quiet. You can respond. Okay, now let us see some examples here. Whatever the examples given. The set E of all even natural numbers can be written as E is equal to X such that X is a natural number and X is equal to 2n for n belongs to n. This is what you have to understand. So to write the rule, you must also have some mathematical knowledge. X is a natural number. Up to that, it's okay. But we want to define only the even numbers. Understand this. Only the even numbers means even natural numbers that are divisible by 2 always. That is why we wrote it like this. X such that X is a natural number and X is equal to 2n for all n belongs to n. Every alphabet, whatever is used by you, every symbol, whatever is used by you must be defined properly. Must be defined properly because the set itself, the name or the definition of set itself, it is the collection of well-defined objects and hence it should be defined properly. So X is such that X belongs to n, X is equal to 2n. It is like this. Or we can write like this. These are the notations. I think everyone knows. We will see symbols also. I have collected a table there for you to understand the symbols. Symbols are very important. Throughout mathematics, you will be getting these symbols. This is read as belongs to. This is read as belongs to. So this is the notation. Similarly, if you take the last one, Rishikesh,
Yes, sir.
please read this, beta.
A is equal to 0, 1, 4, 9, 16 and so on can be written as A is equal to x square such that x is equal to x belongs to the integers.
Yeah. Because you can observe that the beginning element is 0, second element is 1, third element is 4, fourth element is 9. That means it is a perfect square. Every number is a perfect square. That is the reason why it is written like this. A is equal to x square such that x belongs to z. Every real number will not be taken. Only z means only integers will be taken. And if you expand this rule, you will get the roster form. I can say like that. If you say this as the set builder form, you can say this as the roster form. That's what it is. Roster form clearly gives you all the elements, but set builder form gives you only the rule. That's what you have to understand. This is nothing but roster, and this is nothing but set builder. I hope you understand that what I'm saying.
Yes,
Yes, sir.
Okay. अब मिलोनी क्लास में नहीं है?
Yes, sir.
Okay. Right. Let me move to the next part of it. Set builder method or rule method, is it given 2 times or what? Let me check once. Yes, it is given twice. Let me remove it, no problem. Now the symbols here. This is very important, please. Very important. Those who want to take a screenshot of it, you can take it and you can store it and you can keep it under the pillow and you can sleep. Okay. Because all the screenshots are stored in the mobile itself. Anyway, that mobile will be below the pillar only, below your pillow only. That will be fed to your brain automatically. So do that. I'm just joking. Just please, if you write no, that will be more helpful to you. What I'm saying, that will be more helpful to you if you write. So let me read each one. This I need not have to explain. It is implies. This belongs to. This is further we are learning A is subset of B. What does it mean? A is contained in B. A is contained in B. PCM is contained in MJ. What is MJ? MJ is a college consisting of some students and consisting of some sections. Among those sections, PCM is a subset of MJ. So B is MJ, A is PCM group. So PCM is subset of MJ college. Understand it. Don't see that mathematically. Try to understand it with real life applications. That is real time applications, I mean to say. Similarly, this is implies and implied by, or if and only if also we read. This is also read as if and only if. Both are same. Implies and implied by, or if and only if, both are same, please. And both sides will have arrow marks. Okay. Next is opposite to belongs to there. This is belongs to, this is does not belong to. And ST is used means such that this slash will also be used. And it is read like this. X is such that. X is such that X is equal to 2n. Just now we have seen. N belongs to any integer. This is also another form of such that. It is not given there, but ST is the word used. This must be new symbol for you. For every. Generally, mathematicians are lazy. That is why they don't want to write the entire word. That is why they have created symbols here. And of course, these symbols you must understand throughout the mathematics. This will be used. This will be used. So for every symbol, it is V with a horizontal line between. That is, it is inversion of A. A is like this. Inversion of A is for every. This is A. Inversion of A for every. Now there exists. This is a symbol. It is E is there. E. E inverted or mirror image of E, please. Mirror image of E is nothing but there exists. These are the symbols used. Okay. These are the symbols used. Saswat?
Yes, sir.
एक मिनट, ये फर्स्ट वन का एक बार आपको बताने की जरूरत नहीं है. I don't need to say that because it is frequently used. Okay. What is it? Implies. Prasad? Do you hear me, Prasad? Is there, Prasad? Aswika?
Yes, sir.
ये symbols एक बार देख लो बेटा. This is very important. Without these symbols, you cannot solve the problems. Om Naik.
Yes, sir.
Rahul.
Yes, sir.
ये समझ गया ना बेटा?
Yes, sir.
Tanisha.
Yes, sir.
Harsh. Kalim.
Yes, sir.
वो कौन है? वो भयंकर कौन है? वो तेरा प्रोफाइल पिक में. Alessa.
Yes, sir.
ठीक है. Now, these are the symbols, and these symbols, this is a frequently used one, that is IFF stands for if and only if. And how do we understand this? This is nothing but what I say. This is nothing but if and only if is nothing but this one only. Both are same. Implies and implied by if and only if. So if this word is used, you have to understand it is if and only if. And I need not have to explain you. This is A is divisor of B. Symbol, please. A is divisor of B. N set of natural numbers. I or Z set of integers. R set of real numbers. C set of complex numbers. And Q set of rational numbers. Then how do we represent set of irrational numbers? Anyone in the class?
Q dash.
Q dash. Q complement. It is written like this. Q complement or Q dash. Both are same. It is set of irrational numbers. He has not given that. But you must know that. Okay. These are the symbols you must understand. Okay. Now, types of sets. When sets are defined, obviously there will be types in the sets. First one is null set. What is a better example for null set? There are 47 students, I think, in the class today. including me 48. So if I ask you, in the 47 students, is there any student speaking who can speak Telugu? It's my mother tongue. That's why I'm asking you. Is there any student who can speak Telugu? Anyone there? You can show your thumb.
Yes, sir.
Anyone there?
Yes, sir.
Who?
Sir, Maurya, sir.
Maurya, no, you're exempted. You're not there. Yeah, remaining
Oh,
people.
sorry, sir.
Remaining people, please. Anyone there? Those who can speak Telugu? I don't think so. So that becomes a null set now. That becomes a null set. Okay. So what is a null set? There are no elements present in the set, and it is called null set, or in the name itself we have empty set. Empty set or void set, the names just you remember. Void set, if you take the dictionary meaning also, literal meaning also, it gives you the same, and it is denoted by phi. It is read as phi or empty brackets, empty flower brackets like this. So the symbol of null set, the symbol of null set is phi, please, or it can be denoted without any elements in the flower brackets like this, without any elements in the flower brackets like this. Okay, that's what it is. So a set which has at least one element is called non-empty set. What does it mean? For example, if I take any that is containing at least one element, he say at least one element. At least one element means the number of students, those who are appearing for NATA. If I ask you, how many students are planning to appear for NATA in your class? Meloni raised. 2 participants raised. Raise your hand. Yes, NATA. NATA, everyone knows it is architecture examination. 5 participants raised their hand. Okay. Someone messaged also. Let me check. This is Raju Chaudhary, 0, then there it is also empty set. So in the flower brackets, if 0 is there, then it is also an empty set. No, Raju. No, Raju. If 0 is present in the flower brackets, that will not be a null set, please. This consists of an element. It should be denoted like this only, without any element. I hope I answered. I answered Raju's question. If 0
Yes,
is
sir.
there, it is not null set. If nothing is written, it is a null set. Okay. So now the number of students, those who are appearing for NATA, is not a null set in your class. If I ask you in your class, how many of you are appearing for NEET? How many of you are appearing for NEET if I ask from your section? There are some 47 students are there. How many of you are appearing for NEET? No one raised their hand. So 0. It is nothing but a null set. The number of students appearing NEET from this group is an empty set or null set. It is very, very simple. Everyone can understand that. Now, singleton set. In the name itself, I don't want to extend it more, because in the name itself, you can find the meaning of it. That is why I don't want to take any examples also. Singleton set means it consists of only one element. But why I am discussing that much, whenever mathematics comes, whenever the definitions comes, whenever this type of side headings come, you think that this is all mathematics. We don't have any real life applications, but everything there will be a real life application. singleton set. Number of PMs of India. How many PMs are there?
1.
1. PMs of India is a singleton set. Okay. Now, every one of you, a singleton set with respect to marriage. Are you? Anyone married in the class?
No, sir.
Any boys or girls, those who are married in the class? I think no one married. So you're all single there. You're all singleton sets. And even with regards to this class also, you are single. Now no group formed here. You're all listening single. So you're all singleton sets at present due to this pandemic corona. Okay, so singleton set consists of one and only one element. That's it. So you can take lively examples for that one. Now finite set. The number of students of PCM batch is a finite set. Number of students of PCM batch is a finite set because it is countable. It is countable. When it is countable, it is finite. Finite means it's countable. Then what is the cardinal number of a finite set? Cardinal number of a finite set is the number of the number n in the above definition is called the cardinal number or order of finite set A and is denoted by n of A or O of A. So what is n of PCM today, excluding me? Anyone, do you answer?
47.
That's it. So the cardinal number means the number of elements that are present. The number of elements that are present in the
46.
class today is the cardinal number of that set PCM. That set PCM. Okay. Next, infinite set. A set whose elements cannot be listed out. A set whose elements cannot be listed out by the natural numbers 1, 2, 3, so on, and for any natural number n is called an infinite set. Of course, generally the infinite sets, if you take the real number set, we can take, if you take the number line, the number line, you know, it is drawn from minus infinity to plus infinity, which is nothing but infinite set only, because there will be infinite numbers present in between. It is minus infinity to plus infinity with 0 in between. So this is denoted by capital R. So capital R is an infinite set, and we've opened the brackets here. What are the open brackets and closed brackets? I will explain you that also. This is very, very important. Further, everywhere we will be using this interval. This is an interval. This is lower limit. This is upper limit, and this bracket is said to be the open bracket. And what is the meaning of open bracket, what is the meaning of closed bracket, and all this I'll be discussing. Anyway, so in an infinite set we cannot count the number of elements. Okay, next, equivalent set. Equivalent set is that set in which the cardinal numbers are equal. Two finite sets A and B are equivalent if their cardinal numbers are same. That is, n of A is equal to n of B. N of A is equal to n of B. Okay. Now, if I say the number of states of India, anyone, do you answer? General knowledge. Ananya should also answer because you will have GK also as a paper in your examinations. Number of states of India.
28.
29.
29.
29.
Hmm?
29.
Yep.
Pakka?
Yes, sir.
But sir,
Yes,
now
sir.
Jammu Kashmir has been named as Union Territory, no?
तो क्या? So I asked only states, not union territories. I think union territories are now 8 or 9. So number of states of India, let me say, is 29. Number of state capitals of India, obviously, for each state, only one capital will be there. So that is also 29. Okay? Like that. Some lively examples I want to give you like this. Okay. Similarly, if you take different countries in the world, each country will have most generally one capital only. Like that, there will be some summer capital, winter capital, like that there are. But main capital, administrative capital will be only one. So the number of countries on the globe is equal to number of their capitals. Obviously, they are said to be equivalent sets. Remember that. They are said to be equivalent sets. Equivalent means the cardinal number must be same. But equal sets means each and every element must be same. Understand this. Understand the difference between equivalent and equal. Equal sets means every element of set A must be equal to the every element of set B. Then only we can say that those two are equal sets, and we write it as A is equal to B. We write it as A is equal to B. And if A is not equal to B, then the sets A and B are said to be not equal. So symbolically, this is the notation you have to understand. Symbolically, A is equal to B if X belongs to A, if and only if X belongs to B also. Or if you take an element in set A, that element must also present in B. What is X here? Element of A. So that element must also be present in B. Then only we call them as equal sets. But in case of equivalent set, it need not be. Equivalent sets, the cardinal number must be same. That's it. Now, Ananya,
Yes,
please
sir.
read this note.
Equal sets are always equivalent, but equals may need not be equal set.
Is it not visible properly or what?
नहीं
That
सर
language
वो
is not
मेरा
proper.
माइक प्रॉब्लम हो गया था मेरा माइक म्यूट हो गया था
ठीक है. Equal sets are always equivalent, but equivalent sets may need not be equal sets. Okay, obviously, equal sets will always be equivalent, but equivalent set need not be equal sets. Next is universal set. Universal set. In fact, if you take the meaning, literal meaning of the word itself gives you the definition. The meaning, literal meaning of universal, that means a set that contains all sets in a given context is called the universal set. For example, now IPL is going on. IPL is going on. Is it finished? I don't know because I do not like cricket. That is
No,
a,
sir, it is going on.
Going on.
that's
going
a
on.
bloody game. Wastes all the time of the students. That is why I don't like that. I never see that. But I watch only Pakistan India cricket. That's it. Not the remaining. Okay. So, what is a universal set of IPL? How many sets are, how many elements are there in that IPL universal set? Because you watch the cricket, I want to know that because I don't know that. I don't have that knowledge. Let me understand from you. Oh, 8 are there?
yes
Yes,
sir
sir.
That's all.
Yes,
8.
sir.
Oh,
Number of teams you are speaking.
yeah, number of teams, obviously.
Yes, sir. 8.
8 are there. So, all these 8 constitute a universal set. Now, if a game is played by two teams yesterday, that will be an element of the universal set. That will be taken as a subset of the universal set. That means universal set consists of all the sets. All the sets. So that depends again on the context. That depends again on the context. What is a universal set of the world? It must contain the list of all the countries present on the globe. The list of all the countries present on the globe. That will give you a universal set. In that one, India is one of the member, one of the element, I must say, one of the element. So a set containing all possible elements which occur in the discussion is called a universal set and is denoted by U, capital U. So thus in any particular discussion, no element can exist out of universal set. It should be noted that universal set is not unique. It may differ in problem to problem. So that's why he is saying context. Context means it depends on the situation. It depends on the situation. Okay. Now, very important one is the power set. In the name itself, you have the meaning of it. Power set. Power set is that set which constitutes or which consists of all the subsets. All the subsets. So, power set is a set which is containing all the subsets, please. Okay. See this one. I'll take an example and explain you. I have taken a set as 1, 2, 3. Now I need power set of A. I need power set of A. How many subsets that can be formed here? Subset. That means it is contained. A contains 1. 1, 2, single element sets, singleton set, 3, 1, 2,
1,
1, 3, 2, 3, and any more? 1, 2, 1, 3, 2, 3, and 1, 2, 3.
1, 2, 3.
The set itself is a subset.
yes.
So null set can come.
And the set itself is the subset, and one more set is also there, which is null set. Null set is element of power set. For all sets contain, all sets power sets contain, all sets power set contain null set. So null set is subset of every set. Null set is subset of every set. So power set of A is to be written like this: single element taken, double elements taken, triple element taken. That is the set itself, and the null set is there. So this is denoted by P of A. So power set of any set is the set of all the subsets. Power set of any set is formed by the set of all subsets. How many are there? Just let us count it. 1, 2, 3, 4, 5, 6, 7, 8. So 8 are there. So the cardinal number of A is 3. Cardinal number of A is 3. And you will get it as 2 cube. 2 power the number of elements in the set. 2 power the number of elements in the set gives you the power set elements. The elements present in the power set. If there are 4 elements now, it will be 2 power 4. If there are 5 elements now, it will be 2 power 5. If there are n elements now, it will be 2 power n, like that. I hope you understand, every one of you. In the beginning classes, you used to say yes or no, but nowadays everyone is comfortably sleeping, I think, in the class, isn't it?
Yes, sir.
Yes, sir.
Yes, sir. You are saying yes, sir means yes, we are sleeping. Yes, no? That's
No.
what yes, no?
Sir.
Soham. So S is equal to ABC. P of S is I have taken 1, 2, 3, and he has taken ABC. That's it. That's only the difference. And I think Miloni said this. No, this is null set is also a subset.
Yes, sir.
Miloni. Always it is a subset. Okay. So if A is equal to 5, P of A has one element 5. P of A has one element Y. So number of elements of P of A is equal to 1. A is equal to 5 means it's a null set. Null set will have cardinal number 1. So power set of a given set is always non-empty, obviously. If A has n elements, then P of A has 2 power n elements. Just now I have shown it. P of phi is equal to set of phi. Set of phi, understand the difference. If it is written individually as phi, it is null set. If it is written inside the brackets, there is one element present in the set, which is the null set. So P of phi means P of phi. Anyone please, anyone. P of phi is only phi. P of phi is given to be phi. Set of phi. P of phi means one element phi will be there and another set subset phi will be there. So 2 will be there. P of phi. P of phi means phi, set of phi, and double set of phi, and phi comma phi in a set. Like that it can be written. Then you will have 4 here. That is nothing but 2 square. And this is important, you have to understand. This is important, you have to remember is that the number, if A has n elements, then P of A has 2 power n elements. P of A has 2 power n elements. Remember that. Okay. Next, this is a subset.
Sir,
We used this now already. Someone is saying.
sir, can you repeat the last point? P of phi wala point.
Yeah. P of phi is given to be set of phi. I'm not saying simply it as phi. It is set of phi. Set of phi means this set is containing an element by name phi here. Then P of phi means P of phi is already an element phi, and hence you have to understand that this is one element phi will be there in this one. One element phi will be there in this one, and again set of phi will be there. So there are 2 power 1 elements present here. P of phi means there will be one element phi here, phi one element here, and set of phi here, and in the double brackets phi here and triple bracket, and one more set here phi comma set of phi here, like this. That means this will give you 2 square like this. You will understand this again while we work out the problems. If at all any doubts are there, that will be clear in working out the problems. Now, subsets, please. Subsets. In the name itself, we have this set inclusion, means set contains this set, and hence this is said to be subset. So, if A is subset of B, then we write A is subset of B. The symbol is this. This curved part is facing A, and hence A is subset of B. That means B contains A, or A is contained in B. You have to understand like that. B contains A, or A is contained in B, or sometimes they may be equal also. When they are equal, that equality symbol is used. When they are not equal, that equality will not be used. So, what does it mean? This is one set. This is another set. What is that given? A is subset of B given. So this is A, this is B. So A is contained in B. If I take some element, X here in A, obviously this X is present even in B also because it is already there in B. So this is about subset. Like that, if you take a particular set as B, then B will contain many more subsets. So the subset symbol is this. Subset means which is contained in a given set. Which is contained in a given set. That is simple. Every set is subset to itself. That's what we have written here. Just see, ABC is there. What is a set given? ABC. Check it out. S is ABC and this ABC again is a subset. So every set is a subset to itself. The empty set is a subset of every set. That's what I said. The total number of such set of finite set of elements containing n elements is 2 power n. He repeated this. Because they are important. You have to remember. And this is also to be understood properly because you may be getting direct questions on this one in the objectives. Proper and improper subsets. Very simple, I'll tell you like this. If I explain you what is improper subset, then you will understand what is proper subset. Improper subset means if I take a set A, this set A, it contains phi also as its a subset. So A is subset to itself and phi is also a subset to itself. These two are called simply improper subsets. These two are said to be improper subsets. What is the meaning of improper subset? The set itself and the null set are said to be improper subsets. Then what should be proper subset? Anyone in the class now? I expect the answer from you.
Sir,
Yes.
मुझे improper नहीं समझा. I didn't understand improper.
If you take, for example, A is equal to 1, 2, 3, just now I explained you power set of A is nothing but 1, 2, 3, 1, 2, 1, 3,
2, 3, 1, 3.
2, 3, 1, 2, 3, and 5.
Yes, sir.
Now you must have understood.
Yes, sir.
These two are called improper subsets. Boys and girls,
Sir, means they are not equal, that's why they are called improper.
so there are, just a moment, Rishikesh. There will be always two improper subsets for every set. For every set, there will be two improper subsets. So to get proper subsets, you must write total minus improper. If you want proper subsets now, proper subsets is equal to total minus 2. Total is 2 power n minus 2. Minus 2 is improper.
सर
Yes.
सर नल सेट में एक ही improper subset होगा ना?
हाँ, सिर्फ नल सेट का एग्जाम्पशन है, वही पॉइंट पे आ रहा हूँ.
थैंक यू
सर,
हाँ बोलो.
improper मतलब वो equal नहीं, इसीलिए improper हुए ना.
क्या बेटा?
ए मतलब वो खुद सेट ए बी, अभी आपने 1 2 3 और 5 नल सेट दिखाया था, वो improper subsets थे. सर तो वो इक्वल नहीं है एक दूसरे से, इसीलिए वो improper subsets है.
मतलब the set itself and the null set are always improper subsets and rest of them all proper subsets. That's what it is. Let me show you that. Proper and improper subsets. Let us read it. Proper and improper subsets. If A is subset of B and A not equal to B, then A is a proper subset of B. We write it as A subset of B. Equality नहीं है, check करो एक बार. Equality नहीं है इधर. You don't have equality there. What is that?
Yes, sir.
If equality is there, there is chance of A and B becoming equal. So the null set phi is subset of every set, and every set is subset to itself. That is, phi is subset of A, and A is subset to A for every set A. Therefore, these two are said to be improper subsets. Just now I said that. They are called improper subsets of A. Thus, every non-empty set has two improper subsets. It should be noted that phi has only one subset phi, which is improper. सिर्फ ये दो बोल रहा ना मैं. What I am saying is there are two improper subsets for every set I said, but only one exclusion here, one exclusion. That exclusion is for null set, because null set contains only one element as improper subset. Only one element has improper subset. So thus A has two improper subsets if and only if it is non-empty. Non-empty. Important, please. Important. I'm insisting upon this. What I'm saying, any set A has two improper subsets if and only if it is non-empty. Why should it be non-empty? Anyone? Then you have to think like this. Why should it be non-empty? Means what happens if it is empty?
null set रहेगा तो
Null
क्या
set.
होगा?
Null set
Null set
means
रहेगा तो ये क्या आएगा?
it will have only one subset. It is null set, and hence it has only one. But in the rest of the cases, you will have two improper subsets. So all other subsets of A is called its improper subset. Thus, if A is subset of A not equal to B, A is equal to phi, then A is said to be, just to see that, proper subset of B. That is what you have to understand. Okay. Now, what is the time? Now, let us break for 10 minutes, please. Do you need it or not? अरे ब्रेक के बारे में पूछ रहा फिर भी कोई बात नहीं
Yes,
कर रहे
sir.
यार.
Yes, sir.
चाहिए ना चाहिए बेटा, ना चाहिए तो मैं
Yes,
कंटिन्यू
sir.
करूंगा.
चाहिए सर.
चाहिए सर चाहिए.
चाहिए.
थैंक्स बोलो मेरे को. हाँ, फिर से.
Thank you, sir.
फिर से ज्वाइन हो जाएंगे 10 मिनट 15 मिनट के अंदर. ठीक है.
Yes, sir. Yes, sir.
Okay, sir.
Yes, sir.